Here's a video on solving systems by elimination or combination. You'll hear it called both. And first, just a quick intro to why we can do this process that I'm about to show you. If I told you that x equals 3 and y equals 5, and I asked you, what is x plus y? You would tell me, oh, if x is 3 and y is 5, x plus y is 8. Or in other words, x plus y is 3 plus 5, or x plus y is 8. And so this illustrates the idea that if I have two equations, I can add those two equations together by adding straight down. Okay? Now, keeping that same line of thinking, let's go to this first example. Here I've got a system of equations, and I can solve it by just adding straight down. 2x plus a negative 2x is 0x, so those cancel each other out. 3y plus 5y is 8y, and then 11 plus 13 is 24. So I know that 8y is 24. I can solve that equation very easily and find that y is 3. Once I know y, I can just take either of my two equations and use this new value for y that I've just found and simplify. I'm going to subtract 9 from each side. So, if x equals 1 and y equals 3, that means the ordered pair where these two lines intersect is 1, 3. Keep in mind, I just added straight down. Now, we're going to look at this second example. This second example is a little different because in our first example, when I added straight down, those two canceled out because they have the same absolute value, but they have the opposite signs. 2x and negative 2x add to 0. Well, if I were to do that with this second system, nothing would cancel out. I'd have 9x plus 6y equals 0. I still have two variables. We haven't gotten anywhere. I want to eliminate one of these variables. I want one of these to be opposite of that. Well, hopefully we know that I can do anything to one side of the equation as long as I also do it to the other. So I want to take my second row. I'm going to show that like this and say row 2, and I want to multiply that row times negative 1. So if I multiply this side of the equation by negative 1, I have to do the same thing to that side of the equation, and I maintain equality. So that becomes negative 5x minus 3y equals a positive 2. And then I just bring my first equation over. 4x plus 3y equals 2. Now, by not violating any mathematical laws, all I did was multiply both sides of this second equation by negative 1. I've now created a system where when I add straight down, my y values will cancel. I have negative 1x equals 4, so I can divide each side of the equation by negative 1 and get that x equals negative 4. Once again, if I know that x equals negative 4, I can pick either of my two equations. I'll just take my first one this time. And then instead of writing the x, I'm going to write what I know x is equal to. And then it's just a matter of solving. I'm going to add 16 to each side. Divide by 3 on each side and get that y equals 6. So if I were to graph these two lines by putting them in slope-intercept form and graphing them, I would end up with the ordered pair, negative 4, 6. That would be where these lines intersected. Once again, the doozy on this problem was that I had to multiply both sides of my equation by negative 1 so that my y values would cancel out. I looked at those and saw they had the same value, and I had to have the foresight to know that if I multiplied either of my equations by negative 1, I could get my y values to cancel out, which is what the goal is in a problem like this.